What if the most mysterious object in the night sky is not just a comet, not just an asteroid, but something else entirely? What if its path is so precise, so strangely aligned, that seasoned scientists whisper among themselves, could this really be natural? On the 1st of July 2025, an observatory in Chile caught sight of something extraordinary. It was small, faint, and fleeting, yet moving at speeds no ordinary comet could sustain. Within days, it was given a name, 3I Atlas, the third interstellar visitor ever recorded. At first, it seemed to fit within the story we know, icy fragments wandering the void, occasionally brushing past our sun. But soon, small details began to trouble researchers. Its glow was too sharp, its orbit too perfect, its encounters with planets too coincidental. And quietly, in conference halls and private papers, a question began to spread. What exactly are we looking at? Is this object a relic of another star system, a fragment from a world older than Earth itself? Is it simply a comet carrying frozen water and dust across light years of darkness? Or could it be something designed, something guided? The possibility sounds unsettling, almost impossible. And yet, astronomers admit, the evidence does not sit comfortably within our expectations. Even its speed invites unease. Over 200,000 kilometers per hour, fast enough that, if it were aimed directly at us, there would be no defense. No warning system could protect us from such a traveler. Thankfully, 3I Atlas is not on a collision course with Earth, but the thought lingers in the background of every calculation. And then there is the light. Is it only reflecting the sun, like every natural rock and shard we know? Or is there something more, an inner glow, a self-made illumination? If so, what could power such a thing in the emptiness between stars? Each of these questions unsettles not because we already know the answers, but because we do not. Tonight, we will follow this story in full, from its discovery to its mysteries, from natural explanations to the possibilities that frighten even the most rational of minds. We will hear the voices of astronomers, the doubts of physicists, and the quiet worries of those who have spent lifetimes mapping the heavens. And as we walk together through these chapters, we may begin to understand why scientists fear what 3I Atlas really is. Before we continue, a brief moment to pause. This is Sleep Time Discoveries, where we explore the mysteries of space, ancient history, and the forgotten wonders of science. I would love to know, where are you watching from tonight, and what time has the clock struck in your part of the world? Let us know below, and if this journey feels meaningful, join us by subscribing so you can wander with us into the next great mystery. Now, let us return to the skies, to the visitor that arrived quietly but refuses to be ignored, a traveler from beyond our sun that scientists both study and quietly fear. Chapter 1. A visitor no one expected. On a cold, quiet night in the Atacama Desert, the air was thinner than most places on Earth, and the sky above seemed impossibly clear. This desert, often described as the driest place on the planet, has almost no moisture, no haze, nothing to cloud the heavens. It is a place where the stars shine with a brilliance that can almost overwhelm the senses. Here, scattered among the rocky ridges and vast empty plains, humanity has built some of its sharpest eyes, instruments that stare unblinking at the dark. Among them is the Atlas system, the Asteroid Terrestrial Impact Last Alert system. Unlike the grand observatories that capture awe-inspiring images of galaxies and nebulae, Atlas has a far more practical mission. It is a guard, a silent sentinel that searches not for beauty, but for danger, scanning the skies for objects that move, shift, and cross the pathways of planets. Its task is simple, but vital, to give us warning if something ever comes too close to Earth. Most nights it finds nothing unusual, a few faint asteroids, a few drifting comets, small things that pose no threat. But on the 1st of July, 2025, it caught something unexpected. At first, it was nothing more than a point of light against a background of countless others. A small dot that slid ever so slightly across the sky. To the human eye, it was unremarkable. But the algorithms that support Atlas noticed its motion. It was moving differently, not like the steady orbit of an asteroid. not like the slow arc of a comet from the Oort cloud. This was faster, sharper. The system flagged it, and later, when astronomers looked closer, they realized the truth. What they had found was not local, not bound to the sun in the way our planets, asteroids, and comets are bound. Its orbit was too extreme, its speed too great. This was something from beyond, an interstellar visitor. The third such object humanity has ever seen. They named it 3I Atlas, 3I, to mark it as the third interstellar object confirmed in human history. Atlas, after the telescope that caught it. On the surface, the name is simple, but behind it lies a moment of astonishment. In a single night, a new visitor had entered our solar system, a messenger from another star. The discovery itself was quiet, as discoveries often are. No alarms, no flashing lights, just lines of data scrolling across screens, calculations of orbit, and then the pause when those numbers refused to fit the patterns astronomers knew so well. The eccentricity of the orbit was well above 1, the clear signature of something not tied to our sun's gravity, and its speed, already over 200,000 kilometers per hour, made it one of the fastest natural objects ever tracked passing through our neighborhood. When the news began to spread quietly among astronomers, the reactions were mixed. Excitement, of course, a sense of wonder, but also a kind of unease. For decades, scientists had assumed that interstellar visitors would be vanishingly rare. We might hope to see one in a generation, perhaps 2 in a century. But in less than 10 years, humanity had now recorded 3. The first was Oumuamua, discovered in 2017. A long, thin object that defied easy classification. It had no clear cometary tail. It reflected light in strange ways. And as it left our solar system, it accelerated slightly, a behavior still debated to this day. Some argued it was outgassing invisible jets of material. Others, more boldly, suggested it could even be a fragment of alien technology. Among those voices was Harvard astrophysicist Avi Loeb, who argued it could be a probe or the shard of a light sail. His view was controversial, but it lingered. Then, in 2019, came Borisov. Unlike Oumuamua, Borisov looked far more ordinary. It had the features of a classic comet, icy, dusty, with a visible tail streaming in sunlight. For many scientists, this was reassuring. It suggested that not every interstellar visitor would be mysterious. Some, perhaps most, would simply be natural wanderers, comets born in distant star systems and cast adrift into the void. But now, in 2025, the story grew stranger. 3 Atlas did not fit neatly into either category. It showed water ice signatures like a comet, but its brightness did not behave like one. Observations from the Hubble Space Telescope revealed that its glow was unusually steep, a brightness profile sharper and stranger than expected. If it were reflecting sunlight like an ordinary comet, it would need to be enormous, perhaps 20 kilometers across. But if it were somehow generating its own light, it could be far smaller, hundreds of meters, not tens of kilometers. The implications of each possibility were very different. A natural object that large would be incredibly rare. In fact, statistical models suggest such a massive interstellar rock should only pass through our solar system once in 10,000 years, if not longer. The odds are against it. But if it were smaller, self-luminous, then the odds become more reasonable. The trouble is, natural explanations for self-illumination are scarce. Radioactive decay could produce some glow, but the material required would be extraordinary. Internal heat could emit thermal radiation, but the temperatures needed would be unusually high. The remaining possibility, whispered, not declared, is that it might be artificial. Even to suggest it is controversial. Scientists are trained to avoid extraordinary claims without extraordinary evidence, yet behind closed doors some admit to being unsettled. To see a visitor aligned so closely with the plane of our planets, to see it moving so quickly yet so precisely, to see it shine in ways that defy ordinary models, it leaves questions that cannot easily be dismissed. And then there is the timing. Why now? Why again? If interstellar visitors are meant to be so rare, why has humanity glimpsed 3 in under a decade? One answer is that our instruments are better, surveys are sharper, Telescopes like Atlas and Pan-STARRS are designed to notice these fleeting travelers. Perhaps they have always been there, and we were blind until now. But some scientists are not fully convinced. The numbers, even corrected for better technology, feel surprising. And in that surprise lies a quiet, unspoken fear. Not fear of impact, though at over 200,000 kilometers per hour, the damage from such a collision would be beyond comprehension. Not fear of invasion, though the idea of technology hidden in plain sight unsettles the imagination. The fear is more subtle. It is the fear of the unknown, the fear that the universe is not as quiet and predictable as we once thought. That in the vastness of space, things pass by that are not accidents, not random, but something else entirely. In the weeks following its discovery, conversations among astronomers were cautious. Many leaned toward natural explanations. They pointed out that comets can behave in unexpected ways, that dust and ice can scatter light strangely, that alignments, however rare, can still occur by chance. But beneath those careful statements, a few voices asked questions that carried weight. Why does this visitor's brightness defy the usual models? Why is its orbit so unusually aligned with ours? Why now, so soon after the last? Some wondered if we are only at the beginning of recognizing a new truth, that interstellar travelers are far more common than we thought. Others wondered if chance alone can explain such timing. And a few, quietly, considered what it would mean if they are not simply natural wanderers. So the story of 3 Atlas begins with more questions than answers. A faint light caught in the desert sky. A calculation that shows it is not one of ours. A brightness that refuses to fit expectation. And an uneasy sense that something rare is happening too often. Whether it is a comet unlike any we have seen, or something beyond the natural, it has already succeeded in one thing. It has unsettled us. As the object continues its journey, it carries with it the weight of these questions. Questions that remind us how small we are, watching from the edge of our world. Questions that stir both curiosity and quiet fear. And in this balance, between wonder and unease, lies the reason scientists pay such close attention. For the universe has a way of surprising us, and in those surprises may lie truths we are only beginning to glimpse. Chapter 2. The Impossible Path. The strange visitor had been confirmed. It was not ours, not from within the solar system, and already its presence stirred questions. But to understand just how unusual this journey was, scientists turned their attention to its path, the invisible line it carved across the fabric of space. Orbits tell stories, and in this case the story was one of impossibility. Most objects near Earth trace gentle ellipses around the Sun, bound by gravity in predictable cycles. Comets sweep inward from the frozen outskirts, loop in close, and retreat back into the darkness, some taking centuries, others millennia. Asteroids cling to belts between Mars and Jupiter, or wander a little closer before looping back. But this new traveller, 3I Atlas, did neither. Its trajectory was no circle, no ellipse, not even the long loop of a comet. It was a hyperbola, a curve that does not return. That simple truth told astronomers that this was not a resident of our solar family. It was passing through once, and once only, pulled briefly by the sun's gravity before resuming its endless voyage into the void. The mathematics of such paths is straightforward, but seeing one in reality is unsettling. A hyperbolic orbit means there is no second chance, no repetition. This object had drifted in from a distant star system, perhaps travelling for millions of years, only to spend a handful of months in our sky. Then it would vanish forever, never to be seen again. The idea of something so fleeting, so alien to our system, unsettled even the most seasoned astronomers. The numbers carried their own weight. The speed of 3I Atlas was staggering, over 200,000 kilometers per hour. To put such a number into perspective, the fastest spacecraft humanity has ever built, the Parker Solar Probe, travels at about 700,000 kilometers per hour at its closest approach to the Sun. But that is under extreme conditions, diving deep into our star's gravity well, using slingshots from Venus. For an interstellar object entering the solar system, a speed of 200,000 kilometers per hour is extraordinary. Compared with comets, it is even more striking. Most comets drift inward at speeds closer to 50 or 60,000 kilometers per hour, some a little faster, some slower, but always within a range that feels manageable, understandable. 3I Atlas was far beyond. At such velocity, its presence was ghost-like. Moving too quickly to be caught, too fast for any spacecraft to pursue, it was untouchable. By the time instruments registered it, it was already on its way past. Humanity had only a narrow window to observe, and even then, no hope of ever reaching it. That realization deepened the sense of unease. This was not an object to be studied up close, not something to sample or visit. It was a passerby whose secrets would remain, for the most part, untouchable. Yet speed was not the only mystery. Its alignment raised new questions. When the orbital path was plotted against the solar system's plane, the match was uncanny. Only a 5-degree tilt separated its trajectory from Earth's orbital plane, a near-perfect alignment in a cosmos where randomness should dominate. Comets from the Oort cloud come in from every direction, tilted at steep angles, their paths like wild chords across a circle. But this one seemed to skim neatly along the same plane in which Earth and the other planets travel. For astronomers, that coincidence was striking. The solar system is vast, three-dimensional, a sphere of space filled with infinite possible angles of approach. That this traveller should pass so closely aligned with our narrow disc-raised eyebrows, some chalked it up to chance. With enough stars, enough time, perhaps the improbable becomes inevitable. But others hesitated. The neatness of the alignment made the skin prickle. It was as if the visitor had chosen to arrive in the same plane as our world. And then came the numbers that truly unsettled. If, and it was only an if, an object like this were ever to align not just with our plane, but with our planet, the consequences would be beyond imagination. At 200,000 kilometers per hour, the kinetic energy of such a collision would dwarf the combined power of every nuclear weapon ever built. Asteroids like the one that ended the age of dinosaurs struck at far slower speeds, and even then they rewrote Earth's history. This was faster, heavier, and indifferent. The raw equations were cold, and yet the conclusions carried heat. No defense system exists that could stop such an object. Not lasers, not nuclear interceptors. Not even early detection would save us. The sheer velocity would render any response meaningless. And though 3I Atlas was not on a collision course, though its path was safely distant, just running the calculations brought a silence to the rooms where astronomers worked. For in science, imagination is not easily separated from reality. Knowing that such objects exist, knowing that they travel so swiftly, knowing that they can align so nearly with our plane, it was enough to stir the thought of what might be, and even the assurance of safety could not remove the chill. For those who stared at the data, the path of 3 Atlas became a reminder of our fragility. Earth is a small, thin shell of rock and air circling a medium star. For billions of years we have lived in relative calm, with only rare catastrophes reshaping the surface. But the universe does not guarantee safety. Interstellar visitors carry within them the proof that chance governs much of existence, and chance is merciless. Still, there is fascination in such peril. As the equations of hyperbolic orbits filled the pages, as charts showed the neat arcs sweeping through and away, astronomers felt both fear and wonder. To witness such a path is to glimpse the mechanics of the cosmos, the way gravity itself bends and shapes trajectories across infinite distances. The object had likely travelled from a system we will never know, perhaps torn free by the gravitational dance of giant planets hurled outward into the void. For millions of years it drifted, until, by chance, it intersected with ours. And now, for a brief passage, humanity could see it, a guest from beyond, indifferent to the questions it inspired. Night after night, telescopes tracked it. Each observation refined the orbit, each calculation confirming the hyperbola, the speed, the tilt. As certainty grew, so did the curiosity. What forces had shaped it? Was it a fragment of a shattered planet? An icy remnant cast adrift from a star's outer shell? Or something stranger still? The answers remained elusive. But in the midst of this search, the underlying unease persisted. For every calculation that assured safety, another whispered of vulnerability. The truth is, astronomy often reveals not just beauty, but danger. In charting the heavens, scientists confront the scale of what lies beyond, objects of immense power moving in silence. 3i Atlas, in its impossible path, was a messenger of this truth. It showed us the speed at which fate can arrive. It showed us that alignments we call coincidence can still feel like intention. And it showed us that the universe does not pause for our defenses. So as the object continued on its way, slipping ever farther from the sun, there was relief, yes, but also reflection. Relief that this one would not strike, reflection that others could. The impossible path of 3i Atlas was a reminder carved into the sky. We are not the masters here. We are observers, fragile on a small world, watching the endless traffic of the cosmos, hoping the next visitor passes as harmlessly as this. And beneath that hope, the question remained. If visitors are meant to be rare, why have they come so soon, one after another? Is the universe more crowded than we thought, or are we only just beginning to notice? And if we are noticing now, what else waits unseen in the dark between the stars? The answers may never come, but the questions linger, soft and persistent, like a quiet pulse in the night sky. Chapter 3. A glow that shouldn't exist. By now, astronomers were not only certain that 3i Atlas was from beyond our solar system, they were certain too that it carried puzzles with it, puzzles that deepened the longer they looked. The trajectory had been unusual, the speed unsettling, the alignment uncanny. But perhaps the most baffling mystery of all came not from where it was going or how fast it travelled, but from the way it shone. When astronomers study distant objects, brightness is their first and most reliable tool. Light is the messenger, carrying information across the void. By measuring how bright something appears and how that brightness changes over time, researchers can make astonishingly precise deductions about its size, its shape, even its surface composition. Every comet and asteroid reflects sunlight in its own way, its glow shaped by dust and ice, its tail fanning outward like a lantern in the dark. Over centuries of study, astronomers have grown familiar with these patterns. They know what a comet's brightness curve looks like. They know how quickly it rises and falls as the object approaches and recedes from the sun. But when the numbers came back for 3i Atlas, something felt wrong. Its light curve was steeper than expected, its profile sharper, its glow behaving as though it did not quite obey the ordinary rules of reflection. Imagine a mirror that suddenly shines brighter than the lamp it reflects, or a frosted glass that glows more evenly than physics allows. That was the puzzle astronomers faced. At first, it seemed like perhaps the object was simply large. A big enough surface, even with the faint glow of the sun at such distances, might reflect more than expected. And so, early models suggested something enormous, perhaps 20 kilometers across. That would make it vastly larger than Oumuamua, the first interstellar visitor spotted in 2017, which had been no bigger than a city block. It would also dwarf 2i Borisov, discovered in 2019, which was closer in scale to an ordinary comet. A 20-kilometer object wandering through interstellar space was possible, but improbable. The odds of us detecting one so quickly after the last visitors seemed almost absurd. But the brightness did not quite match even that model. The way it rose, the way it seemed steady, the particular curve it traced across the data charts, all of it hinted at something else. Some astronomers began to ask a question that felt almost heretical. What if the light was not reflected at all? What if the object was glowing on its own? The suggestion stirred unease immediately. Natural bodies do not glow in interstellar space, not in this way. Stars glow. Nebulae shine, but a fragment of rock and ice. That was unheard of. Some scientists, cautious by nature, looked for natural explanations. Could radioactive elements within the object be producing heat? But the spectrum of the light did not match. Could it be friction with interstellar gas, faint though it is? But the object had travelled for millions of years, and such friction could not sustain a glow. Could it be that ice sublimating from its surface was catching the sunlight in unusual ways? Perhaps. And yet the numbers did not sit comfortably with that explanation either. One astronomer phrased the problem bluntly. Either we are missing an entire category of astrophysics, or this object is producing light deliberately. Neither answer is easy to live with. It was not a conclusion anyone wanted to draw. Science leans on natural causes, and history has shown again and again that strange phenomena usually find natural explanations. But the discomfort remained. For if 3I Atlas was indeed glowing on its own, it meant energy was being produced. Vast amounts of it. Enough to rival entire power plants on Earth, sustained across unimaginable distances. That energy had to come from somewhere. Even setting aside the unsettling possibilities, the mystery was enough to deepen the fascination. Astronomers began to take longer looks, to analyze the light with more precision. Spectroscopic instruments broke it apart into wavelengths, searching for chemical signatures. There too, the findings were unusual. The glow carried signs of water ice, clean and pristine, unlike the familiar isotopic fingerprints of comets born in our solar system. It suggested that this object had formed under different conditions around a distant star in an environment we could only guess at. Carbon compounds were also detected, and silicate minerals, dust and stone as expected. But none of these fully explained the glow. They were ingredients, yes, but not answers. Instead of clarity, the deeper looks only sharpened the puzzle. And so the question lingered. What was 3I Atlas? A comet? An asteroid? A fragment of some lost world? Or something stranger? Something that fell outside the categories we had prepared? Scientists knew that even raising the possibility of artificial origin would invite criticism, even ridicule. Yet the glow remained, calm, steady, a reminder that nature does not always fit within human boxes. Imagine the quiet of an observatory at night, the telescope's dome turning smoothly against the stars. On the computer screens, numbers scroll, graphs plot their slow arcs. The data shows the glow, steady, insistent. Astronomers sit in silence, tapping calculations, checking and rechecking. The air hums faintly with electronics, but beneath that hum there is a tension, almost like the hush in a library when a mystery novel reaches its turning point. Something here does not fit. Something here is waiting to be understood. For those working closest to the data, the glow was more than numbers. It was a reminder of limits. Our physics is strong, yes. Our mathematics is sound. But the universe is vast, and sometimes, in rare moments, something arrives to remind us that knowledge is never complete. 3I Atlas, shining faintly in the dark, was one of those reminders. If it glowed on its own, then we face two uncomfortable paths of thought. Either the physics we know is incomplete, leaving us blind to entire mechanisms of light and energy we cannot yet explain, or else this object was not entirely natural, and some intelligence, not ours, had left it to wander. Both paths provoked unease. Scientists are used to asking questions, but rarely do the questions carry such weight. And yet, amid the unease, there was also wonder. To sit under the night sky, to know that light from another system had reached us, carrying with it mysteries we cannot solve, is to feel both small and privileged. Small, because we are reminded of how little we know. Privileged, because the cosmos does not often give us such gifts. The glow of 3I Atlas, whether natural or not, was more than a puzzle. It was an invitation to look closer, to stretch our models, to imagine. And so the observations continued. Telescopes tracked it. Papers were written. Debates unfolded. Some leaned toward exotic physics. Others dismissed the strangeness as statistical noise, the byproduct of imperfect data. But none could ignore the lingering sense that something about this visitor defied expectation. It drifted on, the faint glow steady against the backdrop of stars. Night after night, astronomers returned to their instruments, seeking answers. Night after night, the object kept its silence. And so the fear persisted, subtle but real. Not the fear of immediate danger. Its path was clear, its trajectory safe. But the fear of ignorance, the fear of mystery. To look at the glow of 3I Atlas was to confront the edges of our understanding, to admit that even with all our instruments, all our equations, we are still children beneath the stars. Perhaps that is why the object lingered in minds long after each observation session ended. Scientists went home, lay down to sleep, and still the image returned. a faint, inexplicable light moving silently through the solar system, carrying questions no one yet knew how to answer. And in that silence, in that glow, there was both fear and beauty. Chapter 4. Too big or too small? The glow of 3E Atlas refused to be simple. Every attempt to measure it only led to deeper puzzles. Astronomers are used to numbers offering clarity. A calculation narrows uncertainty. A curve on a graph tells a story. But here the numbers split in two directions, and each path carried its own unease. If the brightness was nothing more than sunlight bouncing back, then the object had to be vast. 20 kilometers across, a body so immense that it dwarfed every mountain on Earth. Imagine Everest multiplied and set adrift among the stars. By interstellar standards, such a traveler is not impossible, but it is exceedingly rare. Astronomers likened it to tossing a single grain of sand into an ocean and then expecting it to wash up at your feet almost at once. The mathematics behind such a coincidence strained belief. To encounter one of these giants within the short span of human skywatching seemed unlikely. To find it so soon after Oumuamua and 2I Borisov seemed stranger still. Interstellar wanderers of this size should be rare, 1 in 10,000 years rare. And yet here it was, drifting quietly past, its glow bright enough to suggest enormity. For scientists who deal in probabilities, the numbers whispered something uncomfortable. Either our understanding of how many large objects drift between the stars was deeply wrong, or something unusual had placed this one on our doorstep. That thought carried its own quiet fear. If giants were more common than believed, then the galaxy might be filled with unseen wanderers, silent mountains of ice and rock, gliding from star system to star system. The Earth, delicate in its orbit, has no shield against them. One chance encounter, one unlucky trajectory, and the story of life here could end without warning. Even if 3I Atlas itself posed no danger, the idea that such visitors might be more common than we think unsettled many minds. But the alternative was no less troubling. If the brightness was not reflected sunlight at all, then 3I Atlas might be far smaller. A few hundred meters across, still immense in human terms, like a mountain carried on an invisible current, but tiny compared with the imagined giant. And if such a small fragment glowed on its own, then something profound was at work. Self-luminous objects of this kind do not appear in our natural models. Rocks do not shine. Ice does not kindle its own fire. To accept such a thing is to accept either a form of physics we have yet to glimpse, or the possibility of technology behind the glow. Here the paradox sharpened. Astronomers faced a choice between two paths, neither comfortable. One path led to improbability, a massive interstellar visitor arriving against every statistical expectation. The other path led to impossibility, a smaller body generating its own light in defiance of natural explanation. As one researcher quietly admitted, we are forced to choose between the unlikely and the extraordinary. In the stillness of observatories, that tension was almost tangible. Imagine sitting beneath a vast dome, the night air cool and thin, screens humming softly, data scrolling across them like whispers from the sky. Graphs rise and fall, curves bend steeply. Each line seems to suggest a different truth, too big, too small. Each possibility casts its own shadow across the imagination. Somewhere between the graphs and the silence, an astronomer leans back in the chair, staring at numbers that will not resolve. The paradox itself became the fear. Scientists do not fear questions. Questions are the very heart of their work. But they do fear the moments when evidence splits into roads that both unsettle, when numbers demand belief in either coincidence or miracle. To face the improbable is humbling. To face the extraordinary is destabilizing. And to be caught between the two, with no clear way forward, is to drift in uncertainty, like a ship lost between currents. The scale of the two possibilities only deepened that uncertainty. A 20-kilometer object is a continent in miniature, its bulk capable of altering a planet's surface forever if it struck. To imagine such giants roaming freely is to imagine a galaxy littered with silent dooms, any one of them capable of erasing a world. Yet to imagine a smaller fragment that shines by its own hand is to imagine something designed, something that carries a secret within it. Either way, the mind turns restless. For those who listen to the debate from outside the field, the paradox may sound abstract, but for those who spend their nights beneath stars, it was haunting. They had grown comfortable with comets that gleam only by reflection, asteroids that drift with predictable silence. But this visitor refused to conform, to measure carefully, to calculate with precision, and still find yourself choosing between the improbable and the extraordinary. That is the kind of puzzle that lingers long after the telescope is shuttered. Astronomers spoke of it with voices lowered, not because of secrecy, but because of weight. Science prefers certainty, and here was none. Even when papers were written and numbers printed, a quiet unease trailed every conclusion. Somewhere, at the edge of each argument, lay the awareness that either answer shifted the ground beneath them. One can picture them standing at the edge of their observatories in the small hours, gazing up not at the data, but at the sky itself. The stars burn steadily, indifferent, as they always have. The visitor glides somewhere among them, carrying its paradox. Too big, too small, reflecting, glowing. A silent riddle drifting on currents of gravity older than Earth. And in those hours of watching and waiting, unease mingled with awe. For the fear was never only fear, it was also fascination, the humbling recognition that the cosmos still holds mysteries that will not bend to our models. That is what makes scientists whisper, what makes their thoughts restless. The numbers may say unlikely, the physics may say impossible, yet the sky, vast and untroubled, presents both at once. The visitor offers no explanation, it leaves only questions suspended in the dark, and perhaps that is what unsettles most of all, not that it is too large or too small, but that it is both possible and impossible at once, and that we may never know which truth it carries. The glow remains, soft and steady, a light that should not be, across a body whose size should not exist, and as it moves deeper into the solar system, the paradox drifts with it, an echo that lingers in the minds of those who watch. Chapter 5. Debris of the stars, or technology of aliens. It is one thing to see a rock drifting through space, quite another to begin peeling away its secrets. At first, many scientists assumed 3I Atlas would behave like any other interstellar comet, carrying the frozen cargo of its birthplace. After all, comets are often thought of as messengers from the past, icy time capsules preserving the chemistry of their parent stars. Yet when astronomers turned their instruments toward this visitor, the signals were not so simple. The first surprise came from the shimmering fingerprints of water ice. Through spectrographs, they could detect how the sunlight reflected and absorbed, leaving behind the telltale dips and rises in the light. Those dips whispered of H2O, molecules of ice locked inside the body of 3I Atlas. That might sound ordinary, since comets in our own solar system are mostly ice, but the closer they looked, the more unsettling the pattern became. It was water ice, yes, but not quite like ours. The isotopic ratios, the delicate balance between lighter and heavier forms, were out of step with what solar system comets usually carry. This was ice that had never been melted and refrozen 100 times, never baked by our sun's heat, never reshaped by billions of years orbiting a familiar star. It was pristine, untouched, a kind of purity not seen in the comets we know. Some astronomers whispered that this was what made the object so alien, even if it was entirely natural. Imagine holding a stone in your hand that had been flung from another star system, a place light years away, carrying the chemical memory of suns we have never seen with the naked eye. That was the scientific wonder. But beside it lay unease, because pristine ice also meant unfamiliar physics. It meant that the models built on comets in our own neighborhood might not apply here. And when models begin to fail, scientists find themselves in the dark. The composition did not stop with water. Instruments revealed minerals and silicates, grains not unlike the dust between our planets, yet subtly different in their balances. Carbonaceous matter was there too, the kind of dark soot that often cloaks comets, making them look like lumps of coal drifting through space. But again, the mix was not the same as homegrown comets. This was material likely born under the light of another star, perhaps one younger and hotter, or one older and dying. Each spectrum was like a voice from a foreign world, and astronomers listened with both fascination and unease. Then came the larger question: if these signatures really belonged to a natural body, then 3I Atlas was an unusually well-preserved comet from interstellar space. But if the debris was only a disguise, what then? Some researchers raised the idea that dust and ice could accumulate naturally on the surface of an artificial object, the way barnacles grow on a ship's hull. A craft travelling for millions of years might sweep up grains, layer by layer, until it wore the mask of a comet. To an observer far away, it would appear no different from a frozen lump of rock and ice. But underneath, who could say? Harvard astrophysicist Avi Loeb, who had already stirred debate with his claims about Oumuamua years earlier, once again entered the discussion. He reminded the world that if even a small fraction of such anomalies were technological, it would change everything we thought we knew. His voice was calm, measured, yet it carried a gravity that unsettled many. The possibility was not framed as proof, but as a challenge. Either accept that the universe occasionally throws us objects that defy every expectation, or at least remain open to the idea that intelligence could be behind them. Neither option was comforting. To many scientists, the danger lay not in the alien hypothesis itself, but in the shadows it cast over the natural explanations. For centuries, astronomy has been built on the assumption that the cosmos, though vast and mysterious, follows laws we can understand. Each comet, each planet, each star adds a piece to the grand puzzle. But when faced with something like 3I Atlas, the pieces no longer fit neatly. If it was natural, it was rare beyond belief. If it was artificial, then history itself might already include visitors we had failed to notice. Either way, the solid ground of certainty began to shift beneath their feet. Picture the scene: a control room at an observatory, lights dimmed to protect night-adjusted eyes, monitors glowing with spectral data. A few researchers sit in silence, staring at the screen as the peaks and troughs reveal the object's makeup. At first, the thrill of discovery runs high. Another interstellar messenger, another chance to study a relic from beyond our sun. But then the thrill begins to blur into unease. The numbers do not line up, the ratios are off. The purity is unlike anything catalogued before. Someone breaks the silence. This doesn't make sense. A laugh follows, nervous, but it doesn't dispel the thought. What if it isn't supposed to make sense? It is in those quiet rooms, in the pauses between data sets, that the fear emerges most strongly. Not the cinematic fear of flashing alarms or apocalyptic predictions, but the subtler kind. The realization that we may not have the categories needed to describe what we are seeing. The fear of ignorance, of reaching the edges of our map of knowledge and finding only blank space beyond. Some tried to calm the waters by pointing out that the universe is vast, that rare things will sometimes appear simply by chance. But the voices of doubt were harder to silence. Loeb himself argued that scientists should not dismiss possibilities just because they seemed extraordinary. If we ignore what doesn't fit, we blind ourselves to discovery. That insistence struck some as bold, others as reckless. Was he opening a door toward understanding or toward endless speculation? The spacecraft hypothesis, however fringe it sounded, carried an eerie logic. If you were designing a probe to travel between stars, would you not cloak it in something that looked ordinary? A rocky shell, a coating of dust, a sheath of ice, things the universe is full of. Such camouflage would ensure it passed through alien systems unnoticed, like a spy in plain sight. The longer astronomers stared at the chemical signals, the harder it was to dismiss the possibility, not because they had proof, but because the alternative explanations stretched their probability so thin. As the debate continued, more telescopes joined the watch. Data streamed in from Gemini South, from NASA's Infrared Telescope facility, from Hubble itself. Each new line of information confirmed the presence of water ice, silicates, and carbon compounds. Yet each confirmation only deepened the paradox. Everything about 3I Atlas seemed both familiar and alien at once, like a face in a dream, half recognized, half unknown. And so the scientific community found itself divided. For some, The excitement of studying a new interstellar comet was enough. For others, the unsettling questions refused to quiet down. Why this composition? Why this purity? Why the resemblance to a mask? Could nature really produce such a traveler by chance? Or was chance itself the mask, hiding intention beneath statistics? As weeks passed and the object continued on its path, those questions began to echo in unexpected places. Conferences that would normally be quiet, scholarly affairs suddenly found their panel discussions spilling into heated debates. Words like unlikely and extraordinary appeared again and again in papers and presentations. Each camp leaned on probability, yet the numbers pointed in troubling directions no matter how they were turned. If 3I Atlas were a massive natural comet, its sheer size would make it staggeringly rare, far rarer than its timely arrival suggested. If instead it were much smaller but self-luminous, the very idea pressed against the edges of known physics. And if the surface chemistry was as pristine as it seemed, then its journey must have been unimaginably long, carrying the unaltered fingerprint of stars perhaps born before our own sun. Every explanation sounded improbable, but one had to be true. It was during one such debate that an astronomer, normally cautious with words, leaned back from his microphone and murmured into the hall, "We are forced to choose between the unlikely and the extraordinary." A ripple went through the audience. The sentence would later be repeated in journals, interviews, even quiet conversations among students. It was not the content of the statement that unsettled, it was the tone. Here was a professional scientist admitting, openly, that the available answers themselves were frightening. This was the kind of fear that did not announce itself with alarm bells or breaking news banners. It was the slower kind, the fear of realizing that one's intellectual tools might not be sharp enough for the problem at hand. Astronomers are used to building models, predicting paths, explaining brightness with neat equations. But what if the brightness came from something else? What if the path was not entirely natural? Each new observation seemed to force them further down corridors of thought they were not prepared to walk. The spacecraft hypothesis, though still on the margins, began to attract attention simply because it gave shape to the unease. Loeb's suggestion that a fraction of these objects might be artificial was less about proving aliens and more about asking whether we had blinded ourselves by assuming everything must be natural. If 1 in 1,000 or 1 in a million turned out to be technological, then dismissing the possibility meant risking ignorance of the most important discovery in human history. That argument, simple but profound, stirred as much resistance as it did curiosity. Skeptics pointed out the practical difficulties. A probe capable of shining with its own light for millions of years would require energy reserves beyond our imagination. Even generating a constant glow equivalent to a city's power output seemed nearly impossible over interstellar distances, and yet the numbers did not let go. If the glow was natural, it asked for physics we did not yet understand. If it was artificial, it suggested capabilities far beyond our own. Both paths circled back to the same uncomfortable destination. Our knowledge was incomplete. In the evenings, when observatories finished their data runs and scientists sat together in lounges or cafeterias, the talk often drifted toward this quiet dread. Someone would joke, lightly, that if it were truly a probe, at least it was keeping its distance. Another would reply that perhaps it was only scouting, waiting, recording. The laughter that followed was always thin, fading quickly into silence. The idea was not taken seriously in official papers, but it lingered in the air like a shadow. Once imagined, it could not be easily dismissed. For the public, the debate often sounded exciting, even adventurous. News outlets spoke of alien probes, mysterious visitors, cosmic riddles. But for the astronomers themselves, the feeling was subtler, heavier. It was not about excitement, but about the unsettling weight of data that did not conform. When the natural order resists classification, the mind struggles to rest. Sleep comes slowly when questions press in from the stars. The pristine ice in particular became a symbol of that restlessness. Ice so unblemished that it seemed to have slept untouched for eons, travelling through the black gulfs of interstellar space. What kind of journey could preserve it so well? What vast emptiness had it crossed without being shattered, melted, or eroded? And why did it arrive here, now, in a moment when our telescopes were sharp enough to notice it? Astronomers often warn against thinking in terms of why, for the universe does not operate with purpose. Yet here, purpose seemed to creep uninvited into their thoughts. One scientist, speaking anonymously to a reporter, admitted that what unsettled him most was not the alien hypothesis, but the possibility that our models of interstellar matter were flawed in ways we had never guessed. If we could not explain one visitor, how many others might we have misunderstood? What blind spots still lingered in our theories? For a discipline built on precision, on decades of careful refinement, that uncertainty felt like standing on shifting sand. Others took a darker view. If dust and ice could indeed mask an artificial body, then perhaps we had already been visited many times without knowing. Perhaps the history of our skies held countless unnoticed travelers, sliding silently past while we congratulated ourselves on understanding the heavens. That suggestion, whispered more often than published, carried its own quiet chill. It implied not only that we might not be alone, but that we might not even be aware of how often we had been overlooked. Through all of this, telescopes continued their work. Night after night, instruments captured photons that had traveled millions of kilometers from the sunlit surface of 3I Atlas. Photons carrying coded messages about ice, rock, and dust. Teams passed them, argued over them, tried to fit them into models. Yet the unease persisted. Each new dataset seemed to confirm the paradox rather than resolve it. Too big or too small, too familiar or too strange, too natural or too deliberate. Each time the puzzle was approached, the pieces rearranged themselves into a different, unsettling shape, and so the debate lingered, unresolved. On one side, the comfort of assuming it was simply a comet, rare but natural, an icy relic of another star. On the other, the possibility that it was something more, something that wore the guise of nature while carrying secrets beneath. Between the two stretched a chasm of probability and fear. In the end, what frightened many scientists most was not the prospect of aliens, nor the thought of unknown physics, but the recognition that both possibilities were larger than us. To accept either was to admit that our understanding, so carefully built, was not yet enough. And in the quiet of observatories, in the hours when data scrolled silently across screens, that admission carried a chill deeper than the vacuum of space itself. Chapter 6. The Dance of Coincidences. The deeper astronomers studied the path of 3I Atlas, the more the orbit itself began to feel like a character in the story. At first glance, it was simply a hyperbolic trajectory, the kind one expects of an interstellar object not bound to our sun. A brief visitor, a wanderer just passing through. But as the numbers filled spreadsheets and simulations, something strange began to emerge. The orbit was not just unusual, it seemed unnervingly well choreographed. It was tilted by only about 5 degrees from the ecliptic plane, the thin sheet of space where nearly all planets travel around the sun. That alone made some astronomers pause. Most interstellar visitors should come from random angles, like pebbles tossed across a pond. They might skim the solar system on steep diagonals, dropping in from above or below. Yet this one seemed to slide almost perfectly along the planetary plane, as though joining the dance of our worlds with uncanny grace. The chance of such close alignment was estimated at just 2 in 1,000. Not impossible, but not the kind of number that lets scientists sleep easily. And then came the encounters. As the orbital path was plotted forward, predictions revealed that 3I Atlas would make unusually close passes to several major bodies. Mars first, just under 30 million kilometers away. Astronomically distant by everyday standards, but remarkably near for something crossing from another star system. Later, it would skim past Jupiter at a similar distance, and in between, it would dip closest to the Sun, performing a perihelion passage, while Earth happened to be on the exact opposite side, hidden from view by the blinding solar glare. One coincidence is expected, 2 might be chalked up to chance, but 3, unfolding in sequence, began to feel unsettling. A statistician reviewing the probabilities remarked quietly, "Coincidences happen. But 3 in a row? That's something else." The numbers suggested odds of 1 in 20,000 that such encounters could occur by accident. Some smiled at that and shrugged. After all, rare things do happen. Others felt the weight of the improbability pressed down on them. The universe has no obligation to line up its dice this way. Yet here, it had. The Mars flyby captured particular attention. The timing was precise, early October, when the planet would be well positioned for observation. Some proposed using orbiters already circling Mars to catch images, to scrutinize the visitor from a vantage point Earth could never offer. There was excitement in that, yes, but also something sharper beneath the surface. If the object had been designed, it could hardly have chosen a more dramatic stage. Passing so close to a world that has fascinated humanity for centuries, a planet where our machines already rove and record, felt almost theatrical. Scientists reminded themselves not to anthropomorphize. But the thought lingered. The perihelion was even stranger. At the end of October, 3 Atlas would swing behind the Sun relative to Earth, vanishing into the brilliance of solar glare at the very moment it reached its closest approach. In other circumstances, this would simply be a frustrating observational gap, one of many that astronomers accept as part of their work. But when some began to frame it differently, the tone shifted. If one wished to conduct a maneuver unseen by Earth's telescopes, they said, this would be the perfect time. It was Avi Loeb who suggested the unsettling phrase, a reverse Oberth maneuver. Normally, spacecraft use the Oberth effect to gain speed by firing engines near a planet or star, where gravitational pull magnifies the thrust. But in this speculative reversal, an interstellar craft could instead use thrust to slow down, shedding velocity while hidden in the Sun's glare. A braking strategy, allowing it to linger rather than speed away. The idea was theoretical, almost fanciful, yet the geometry of the orbit gave it teeth. The coincidence of invisibility was simply too neat. For those already skeptical, this was little more than imaginative storytelling. But for others, the pattern was hard to ignore. Mars, the Sun, Jupiter, all lining up for close encounters, all within a span of months. If it were just a comet, then it was a comet with an unusual talent for dramatic timing. If it were something else, then perhaps the timing was no accident at all. And here was the discomfort. Science does not deal in perhaps. It deals in data, in models, in repeatable observations. Yet the orbit of 3I Atlas, once calculated, needed no imagination to seem suspicious. The fear that crept into conversations was not the fear of impact. This object would not strike Earth. The fear was subtler, rooted in the recognition that its path looked too deliberate, a path too precise to dismiss, too coincidental to ignore. Scientists are trained to resist leaps of interpretation, but they are also trained to respect statistics, and the statistics whispered that chance alone seemed insufficient. Some tried to soothe themselves with reminders of selection bias. After all, we notice strange alignments precisely because they are rare. If 1,000 interstellar objects passed through unnoticed, perhaps 1 or 2 would seem unusual, and we would latch onto them, exaggerating their significance. That reasoning comforted some, but not all, for the question remained, why had we already seen 3 such oddities in less than a decade? Oumuamua, Borisov, and now Atlas. Interstellar visitors should be separated by millennia. Yet here they were, lining up as though on schedule. The mood in observatories grew contemplative. At night, as telescopes tracked the faint glow of 3 Atlas, astronomers found themselves staring at computer screens longer than necessary, watching the simulated arc bend across solar system maps. There was a grace to it, an elegance almost musical. But in that elegance lay the unease. Too graceful, some thought. Too aligned. It was like watching a dancer step into a room uninvited and realizing the steps matched a rhythm only they could hear. In quiet interviews, some scientists admitted the strangeness aloud. If this is chance, one said, then it's the kind of chance that makes you wonder about the nature of chance itself. Another remarked that the orbit had a quality of intention, though he quickly added that intention was not a scientific term. Yet even the caution in their words betrayed something deeper, the recognition that the universe had just presented them with a puzzle that brushed the edges of philosophy as much as physics. The closer the flybys approached, the more this sense of suspense grew. October would bring Mars, late October the Sun, and then Jupiter beyond. Each step a beat in a rhythm that felt too deliberate, too rehearsed. For the public, it was a story of cosmic coincidence, a curiosity to follow in the news. For those who studied orbits for a living, it was a quiet trial of faith in the randomness of nature. How many coincidences does it take before the mind begins to whisper of patterns? And so the orbit of 3i Atlas became more than just numbers on a chart. It became a mirror, reflecting the unease of those who watched it. For in its path, both ordinary and improbable, lay the reminder that the universe is not obligated to conform to our expectations. Sometimes it delivers randomness so perfect it feels like design. Sometimes it offers alignments so unlikely that even seasoned scientists pause, wondering if chance has played a deeper trick. In the end, the fear was not that 3i Atlas would strike us, or even that it might be artificial. The fear was that its path revealed how fragile our confidence in chance really is, how quickly statistics can turn from comfort to discomfort, how swiftly the dance of coincidences can feel like choreography. And as the object slipped silently closer, carrying its mysteries past Mars, toward the Sun, and then out again toward Jupiter, that feeling deepened. The numbers had spoken, but what they were saying depended on who was listening. Chapter 7. The Puzzle of Hidden Energy. In the quiet halls of observatories, beyond the hum of computers and the sharp focus of telescopes, a deeper question began to take shape. Not about where 3i Atlas was headed or what path it followed, but about the very essence of its presence. What unseen force could power this mysterious traveller, casting light where none should be? Tonight we explore the delicate riddle of energy that defies explanation, as we drift gently into the heart of the unknown. The coincidences of the path still linger in the mind. The way 3i Atlas seemed to brush past Mars, skim near Jupiter, and slip behind the glare of the Sun, as though every motion had been traced with a careful hand. But once the trajectory had been debated, calculated, and argued over, another question rose, quiet but heavier. If this object was more than stone and ice, if it was truly shining with its own light, then where exactly was all that power coming from? Astronomers like to measure brightness the way sailors once measured distance on the sea, not with certainty, but with inference. You look at the light, you assume it is reflected, and you calculate the size. But 3i Atlas refused to fit that model neatly. The glow was not what it should have been. It was too steep, too intense, and too steady. And when they ran the numbers, when they allowed themselves to whisper the possibility that it was glowing by itself, they ended with a figure that felt almost absurd: 10 gigawatts. 10 gigawatts is not a number most people carry in their imagination. It is not a candle, nor a lantern, nor even a city block lit at night. It is the combined output of several large power stations, each humming and burning, feeding whole regions of a nation. If you imagine standing on a hill and watching an entire metropolis, every home, every skyscraper, every streetlight burning, you might begin to picture what 10 gigawatts can sustain. To think that a lone traveller from the stars, a fragment no larger than a mountain, could be producing that much energy on its own was enough to make even the most careful scientist pause. The first refuge, of course, was to search for natural causes. Could radioactive decay inside the body of the object produce such a glow? Heavy elements like uranium and thorium do shed heat as they fall apart atom by atom. On Earth, this decay warms the crust beneath our feet, driving the slow churning of magma. But even if 3i Atlas were a lucky repository of such elements, the numbers failed to add up. A natural fragment rich enough to shine with gigawatts would have to be almost a solid nugget of fuel, something nature does not assemble casually. The next thought was geothermal heat, the quiet radiation of warmth from within. Many moons in our solar system do glow faintly from the tug of their parent planets, friction heating their cores as they flex with gravity. But 3i Atlas drifts free, alone, far from the embrace of any massive body. There is nothing to knead it, nothing to pump heat into its interior. And even if there were, the power required would dwarf what tidal forces can provide. Each natural explanation, when stretched, broke apart. Some clung to the possibility of chemical reactions within the ice, long simmering fires of trapped gases or exotic compounds. Yet no reaction known in chemistry could run so strongly, so continuously, across millions of years. One by one, the natural lanterns were snuffed out, leaving the night darker than before. And so the imagination, reluctant but restless, turned toward the artificial. 10 gigawatts is not beyond human comprehension. After all, we can produce it ourselves, here on Earth. Nuclear plants, solar farms, hydroelectric dams all touch that scale. But we can do so only with infrastructure spread across landscapes, with thousands of workers maintaining it, with fuel transported and replenished. To imagine a solitary object, wandering interstellar space for perhaps millions of years, carrying that kind of steady power, that was something else entirely. Scientists began sketching parallels in quiet papers and late-night conversations. What if the glow were not a byproduct of decay or heat, but of intention? Could it be propulsion, a craft bleeding light as it adjusted its course? Could it be illumination, a beacon not meant for us, but for something else, a signal thrown like a flare into the night of the galaxy? Or was it something more mundane, the equivalent of exhaust heat, the waste product of engines running silently inside? The human mind is both bold and cautious when it faces such ideas. For every whisper of a machine, there is a shout of caution. Extraordinary claims require extraordinary evidence. Most astronomers resisted the leap. They pointed again to dust, to ice, to models not yet refined. But even in their resistance, the weight of the numbers pressed down. 10 gigawatts was not easy to dismiss. Imagine standing on the frozen plains of Antarctica at night, where the stars blaze like silver fires overhead. If, in that stillness, a mountain began to glow with the light of a city, no flame, no fuel, just silent radiance, what story could you tell yourself to remain calm? For some, that is what 3i Atlas felt like. A mountain drifting through the dark, shining not because of the sun, but because of something within. Some physicists attempted to soften the paradox. Perhaps the brightness was an illusion, a quirk of how we measured. Perhaps what we thought was self-illumination was simply an unusual scattering of sunlight, grains of dust reflecting light at steep angles. But the profiles, the curves of intensity traced on paper, resisted easy smoothing. And as data came in from Hubble, from Gemini South, from infrared observatories, the puzzle only sharpened. The glow was real, the output was immense. The fear here was subtle, but persistent. It was not the fear of invasion or science fiction weapons. It was the quieter fear of being wrong, of discovering that our understanding of physics is incomplete in some essential way. If it was natural, then the rules we have trusted about comets and asteroids are missing entire chapters. If it was not natural, then something, somewhere, had written those missing chapters long before us. And what would it mean to know that? A civilization capable of carrying a power source across the abyss between stars, sustaining it for ages longer than our species has walked upright. That would not be a neighbor like any we have known. That would be a presence so far ahead that our questions might sound like the cries of children. The numbers haunted in another way too. 10 gigawatts, if it were propulsion, would not simply light an object, it would drive it. An interstellar craft using that energy could accelerate, brake, maneuver with grace. And yet, to our telescopes, 3i Atlas moved with deceptive calm, tracing a path that could still be mistaken for the natural fall of a comet. Was it masking itself? Or were we seeing only a fraction of its true performance, like shadows on a wall? Even among those who resisted the alien hypothesis, the question of sustainability was chilling. How could any system run for so long without failure? Here on Earth, every machine we build, no matter how clever, breaks down, corrodes, or fails. But if 3i Atlas has been glowing on its own across untold light years, then someone, or something, has solved problems we cannot yet dream of solving. Longevity, endurance, reliability on cosmic scales. The quiet conclusion whispered in the halls of observatories was this: either our physics is not what we thought, or we are not alone, and neither option is entirely comforting. To find gaps in physics is to admit that the universe hides more from us than we imagined. To find company in the dark is to admit that our place is smaller, perhaps more fragile than we hoped. Some tried to frame the problem more gently. Perhaps it was not a beacon or an engine. Perhaps the glow was nothing more than trapped energy slowly leaking from ancient collisions, a kind of embers smouldering unseen until now. The galaxy is vast, they reasoned, and strange things can happen. But again, the mathematics pulled them back. The ember would have cooled by now, the light should have faded, and yet 3i Atlas gleamed. The deeper they looked, the more the object became a mirror for our own uncertainty. To some, it was a comet that forced us to sharpen our tools, to refine our equations. To others, it was a messenger, not necessarily hostile, but not easily ignored. And in either case, it was a reminder of how little we truly know. As the weeks passed, telescopes kept their gaze. The data points grew, the graphs lengthened, but the light did not dim. 10 gigawatts remained the figure on the page, stubborn, implausible, unavoidable. And so the debates turned slower, more hushed. This was no longer about quick headlines or bold claims. It was about a quiet reckoning, a recognition that something out there, in the cold silence between stars, was forcing us to rethink what is possible. Perhaps that is the greatest fear of all. Not invasion, not destruction, but change. Change in our picture of the universe. Change in our sense of certainty. Change in the idea that we have even begun to map the limits of what can be. 3i Atlas, with its quiet glow, asked us a question without words. Are you ready to discover that you know less than you thought? And as the object drifted onward, burning with the steady power of 10 gigawatts, the question remained unanswered. Scientists, like the rest of us, could only watch, measure, and wonder. Chapter 8. Watching the Watcher. Once the trajectory was traced, the energy calculated, and the possibilities debated, a quiet but undeniable next step remained: to observe. To turn the most powerful eyes humanity has ever built toward this mysterious traveler. What would it reveal when illuminated by the sharp gaze of our greatest telescopes? As light from distant stars and distant worlds streamed into our lenses, a new question began to take shape. Not about where 3i Atlas came from, but about what its faint glow was trying to tell us. It is one thing for an object to wander into our skies, to slip across orbital paths and bend the laws of probability as though chance itself had been rehearsed. But it is another thing entirely to stare at it through the most powerful eyes humanity has ever built, and to realize that even the instruments themselves seem uncertain about what they are seeing. After all the calculations of its trajectory, after the uneasy reckoning with its energy and glow, the next step was simple: to watch. To point our lenses outward and let light return with its quiet testimony. Yet what those glimpses revealed did not quiet the worry. If anything, they deepened it. The Hubble Space Telescope was among the first to focus on 3i Atlas. Orbiting high above the Earth's atmosphere, free from the distorting blur of air, Hubble has served as our most trusted eye for decades. It has seen galaxies in their infancy, stars collapsing into remnants, and planets wrapped in storms larger than our world. But when it turned its gaze toward this faint traveler, astronomers were struck by something dissonant. The glow of the object was not steady. It pulsed gently, almost imperceptibly, as if a lantern in the dark were breathing. Normally, comets brighten in predictable ways, their surfaces shedding ice that vaporizes into long tails, sunlight scattering through that cloud. But this glow came in patterns, irregular rhythms that stubbornly resisted explanation. Was it a trick of geometry? A rotation that aligned reflective surfaces in unusual ways? Or was there, impossibly, some deeper mechanism flickering within? Those who studied the data tried to keep their tones steady, to anchor their words in the calm of statistics. Yet beneath the figures lingered unease. If light itself was betraying uncertainty, what else might they be overlooking? They wrote down the numbers, logged the graphs, but in private some admitted the thought that clung to their minds. Light does not normally behave this way unless it has reason. Gemini South, a great ground-based telescope in the Chilean Andes, added its voice to the chorus. Perched at nearly 3,000 meters above sea level, under skies so clear that the Milky Way stretches like painted glass from horizon to horizon, Gemini South opened its infrared eyes on the object. Infrared has a way of peeling back disguises. It does not see color in the way our eyes do, but rather the subtle warmth that surfaces give off. When those instruments passed the faint heat of 3i Atlas, they returned a profile both familiar and alien at once. The signatures spoke of pure water ice, astonishingly pristine, unmarked by the dust and organics that normally coat comets born in our solar nursery. To call it clean would be an understatement. It was immaculate, So much so that one researcher murmured to a colleague, "It looks new," as though it had not wandered for billions of years through the harshness of interstellar space, as though it had been fashioned or preserved, kept untouched until this very crossing. Could nature alone have protected such purity? Could chance really have sculpted such a flawless shard and sent it into our skies? The more one asked, the more silence seemed to answer back. And still, the watchers multiplied. The James Webb Space Telescope, newly stationed at its distant post 1,000,000 miles from Earth, was placed on the list of upcoming observers. Webb's gold-coated mirrors are unlike any telescope before it, crafted to capture the faintest whispers of infrared light from galaxies billions of years old. To point such a tool at a wandering visitor within our own celestial backyard would be like asking a master painter to sketch a single grain of sand, an almost trivial task for such an immense power. Yet the anticipation was palpable. What if Webb's clarity stripped away the last excuses? What if it confirmed that the light was not only unusual, but impossible? Astronomers spoke of data, of graphs, of careful schedules. But beneath their professionalism, there was something closer to nerves. To invite Webb into this mystery was to risk removing the veil completely. And there was always the human question, unspoken but present. What if the truth was not one they were prepared to know? Farther still in the future, other eyes waited. The Vera Rubin Observatory in Chile, with its vast survey capabilities, promised to scan the skies nightly, compiling a living movie of celestial change. Every asteroid, every comet, every flicker of supernova light would find its way into its immense catalogue, and among those nightly sweeps, the tracks of 3i Atlas would appear like a secret repeated over and over again. Rubin would not only watch it but record its behaviour in exquisite day-by-day memory. If patterns emerged, Rubin would find them. If coincidences multiplied, Rubin would note them. And even the orbiters circling other worlds, the silent sentinels above Mars, the spacecraft lingering in solar orbit, were drafted into the vigil. Their instruments, though never designed for such a task, might still add stray glimpses, puzzle pieces to be fitted together. It was as though all of humanity's eyes, scattered across the solar system, were now bent toward this single point of strangeness. The watcher, it seemed, was being watched in turn. Yet this act of watching was not as comforting as one might imagine. To watch is to admit ignorance. To train telescope after telescope upon a visitor is to say, "We do not know what you are, and we must look harder." And sometimes the harder one looks, the less certain the picture becomes. Hubble gave rhythms of light, Gemini gave icy purity, Webb promised detail so sharp it could confirm or undo entire theories. But none of them could answer the simplest question at the heart of the unease. Why? Why here? Why now? Why this particular form, this particular glow, this particular purity of ice? In the quiet of the observatories, in the stillness of computer screens flickering with graphs, scientists sat with that why. And the fear did not come from monsters or collisions, but from the very possibility that the universe was whispering something beyond their comprehension. If this object was natural, then the physics of comets needed rewriting. If it was not, then someone, somewhere, had mastered energies and engineering that dwarfed our imagination. Neither answer felt safe. One astronomer, gazing at the shifting bands of data on her monitor, whispered to a colleague, "We are being watched too, you know." She did not mean cameras or satellites. She meant that by staring into this enigma, humanity had entered a dialogue it could not fully control. To watch is also to be aware that perhaps the thing you watch has purpose of its own. What would it feel like, you might wonder, to stand on a hillside as Hubble and Webb and Gemini turned their gaze outward? The night around you dark and hushed, the dome of stars above, and somewhere within that dome, a tiny traveller, reflecting and glowing with patterns you could not quite explain. Would you feel small, as though caught in the immense sweep of history? Or would you feel oddly connected, as though a presence from beyond was brushing, ever so slightly, against your world? These are gentle questions, the kind you might turn over as you drift towards sleep. Could such an object, wandering between stars, ever be lonely? Could it carry with it the memory of the void, the silence of 1,000 light years, the weight of secrets not yet ours to know? Or is it simply stone and ice, indifferent, its mysteries no more deliberate than the fall of rain? Scientists, for all their calculations, wrestled with the same dichotomy. The instruments brought numbers, but the numbers only widened the field of possibilities. Light that pulsed, ice that gleamed too cleanly, orbits that bent probabilities beyond comfort. And still they waited, for Webb to report, for Rubin to scan, for time itself to unfold the answers. Waiting became its own kind of fear, because waiting meant that the truth, whatever it was, had not yet revealed itself. And so, the watchers continued their vigil. Hubble circling high above Earth, Webb stationed in its silent post far beyond the moon, Gemini gazing from its mountain peak, Rubin soon to awaken with nightly surveys. Each telescope, each lens, each mirror turned toward the same enigma. Humanity, in its scattered, fragile way, had chosen to keep looking. The glow in the dark had been noticed, the question had been asked, and now, whatever the answer might be, there could be no pretending it had never arrived. Sleep, if you let yourself drift now, may carry you with those telescopes. You may find yourself floating beside Hubble, watching the slow arc of Earth's blue glow below, or standing beside Gemini, the Andes vast and quiet beneath the Milky Way, or hovering with Webb, balanced in the cold equilibrium of deep space, golden mirrors reflecting starlight. And in every place, the same faint light reaches your eyes, the glow of a traveller whose nature is not yet known. You watch it, and perhaps, just perhaps, it watches you back. Chapter 9. The Bigger Picture. When one object drifts across the sky, it can seem like a solitary note in a vast silent symphony. But when others follow, one after another, a pattern begins to emerge. A rhythm of arrivals, each stranger than the last, each defying expectation. What story might these visitors be trying to tell us? What larger picture begins to take shape when we look beyond a single anomaly and gaze instead at the quiet procession of the unexplained? And so, we step back and listen. It is often said that to understand the present, one must look to the past. The strange presence of Three-Eye Atlas in our skies is not an isolated story. It belongs to a pattern, a quiet sequence of arrivals that began only a few years ago, each one challenging assumptions that astronomers had long held to be unshakable. To trace that pattern is to widen the lens, to step back and see not just a single visitor, but a procession of mysteries drifting through the solar system. And that wider view, for some, is where the unease deepens. For if Three-Eye Atlas is one piece of a puzzle, what image do all the pieces together begin to form? The first of these unexpected guests was Oumuamua, discovered in October 2017. At first, the name itself carried a sense of poetry. In Hawaiian, it means scout or messenger, as if nature itself had whispered to us that this was something sent from afar. Astronomers watching it through their telescopes realized quickly that this was no ordinary comet or asteroid. Its path was hyperbolic, not elliptical. That meant it was not bound to the gravity of the sun. It had come from outside, an interstellar traveler, a stone wandering between stars. But even in that first astonishment, new questions grew. Oumuamua was small, perhaps only a few hundred meters long, yet it reflected sunlight in a way that was puzzling. Its brightness varied dramatically, as if it were tumbling end over end, its shape elongated, almost cigar-like. Some compared it to a shard, others to a flattened disk. And then came the strangest clue. It accelerated slightly as it left the solar system, as though some gentle push were nudging it from behind. No jets of gas or dust were detected, yet it moved with a subtle thrust that no simple explanation could quite account for. For most astronomers, this was a curiosity, a riddle left unsolved. But for a few, it was something more. If it was a fragment of rock, why was it shaped so unusually? If it was a comet, why no visible tail? And if it was just drifting, why did it change speed? Harvard's Avi Loeb, already a bold voice in astrophysics, suggested it could be a fragment of alien technology, perhaps a light sail, a thin sheet propelled by starlight itself. Others dismissed the idea, preferring to keep the question in the category of natural but odd. Yet the unease lingered, tucked away in the back of scientific minds. Then, just 2 years later, in 2019, came the second visitor, 2I/Borisov. Unlike Oumuamua, Borisov looked more familiar. It had a clear cometary tail, venting gas and dust as it warmed under the sun. Its orbit too was interstellar, another hyperbolic path, another traveller simply passing through. But the shock was not in its behaviour, the shock was in its very presence. Astronomers had always calculated that interstellar comets must be rare, so rare that only one might be expected in a century or perhaps longer. Yet within the span of just 2 years, humanity had seen 2. This was a statistical tremor, a sign that something was wrong with the old assumptions. If the galaxy were truly seeding such objects everywhere, perhaps they were far more common than anyone had dared to expect. Or perhaps, as some wondered in hushed tones, the rarity was not in the objects themselves, but in the timing. Why were they appearing to us now, in this thin slice of history, as though clustered around our age of space telescopes and deep observation? Were we watching them, or had they been arranged so they would be watching us? 3I Atlas, discovered in 2025, made the third. And suddenly, what once looked like rare chance began to look like a sequence. First a shard of mystery with no tail, then a comet that seemed normal but arrived improbably soon. And now Atlas, the brightest, the strangest, the most perplexing of them all, glowing, aligned, and far too coincidental in its journey through our neighbourhood. 1 guessed might be chance, 2 might be rare coincidence, 3 begins to look like a pattern. Astronomers keep lists, neat catalogues of data points, but behind the lists are human minds, and human minds are attuned to patterns. They cannot help but notice when events fall in suspicious succession. To some, this succession whispered of a new astronomy. Perhaps the galaxy is indeed filled with a stream of interstellar wanderers, and only now are we building instruments sensitive enough to catch them. But to others, the thought pressed in more tightly. If even one of these visitors were not natural, if even one carried the signature of deliberate creation, then the fact that we have seen 3 already would imply something extraordinary. It would mean that humanity, in its short moment of careful watching, has already brushed against multiple emissaries, multiple scouts. And if scouts exist, they usually serve a purpose. Imagine for a moment standing in a quiet desert at night. The stars arch overhead in infinite stillness. You have always believed that no one else has ever crossed this land. And then, within the space of a few nights, you see 3 sets of footprints appearing in the sand. One looks strange and hard to identify. The second looks ordinary. The third glows faintly in the moonlight. You might still tell yourself these are natural marks of wind or animals. But in the back of your mind, the thought would not rest. Perhaps someone has been walking here, unseen, all along. Oumuamua, Borisov, Atlas. Each carries its own flavour of enigma. The first left us wondering about shapes and sails, the second about frequencies and probabilities, the third about power and intention. And each one deepened the scientific debate. If comets and asteroids from other stars are this frequent, then our solar system is not as solitary as we once believed. We are part of a cosmic thoroughfare, a region that objects pass through in their long journeys across the galaxy. Yet this metaphor of a thoroughfare also carries weight. Roads are rarely empty. If the path is travelled, who, or what, might be travelling upon it? The Vera Rubin Observatory, newly operational, has already begun to tilt the scale of expectation. Designed to scan the sky night after night, it is expected to reveal dozens, perhaps even hundreds, of interstellar visitors in the coming decades. To scientists, this is thrilling, for it means data, samples of probability, a chance to rewrite the statistics of the universe. But hidden in that thrill is the quiet unease. If every year brings another visitor, then the chances rise that not all will be ordinary. Among them may be one that glows too brightly, one that moves too precisely, one that seems to know too much. And the question then is not whether we can study it, but whether we are the ones being studied. Astronomers rarely admit fear openly. Science thrives on objectivity, on the steady hand of reason. Yet even in papers and conferences, phrases slip through: unusual, unprecedented, difficult to explain. These are the scientific equivalents of raised eyebrows, of sleepless nights. And in private, when words are less guarded, Some admit to a deeper worry. If there are technologies adrift in space, passing by quietly, then perhaps we are not the first to look outward. Perhaps we are the latecomers, blinking awake in a galaxy that has long been aware. For the listener, for the dreamer drifting into the rhythms of these stories, the larger picture is both soothing and unsettling. The universe is not empty. It is alive with motion, filled with stones, ice, dust, and perhaps more. Every visitor is a reminder that we are part of something vast, a web of travel and exchange that stretches beyond imagination. Yet in the soft hours of the night, one cannot help but ask, what if some of these stones are not stones? What if some of this dust is not dust? What if, among the countless natural messengers of the stars, there are a few that were built, launched, and sent with eyes turned outward? The fear scientists speak of is rarely fear of monsters or invasions. It is subtler than that. It is the fear of recognition, the moment of realizing that we are not the first to wonder, not the first to explore, not the only ones who leave traces in the cosmic dark. To confront that possibility is to confront a mirror held up to our civilization, reflecting back questions we are not sure we are ready to answer. How would we respond if we knew we were being observed? Would we welcome it as connection, or fear it as surveillance? Would we feel curiosity, or would we feel small? And so, the bigger picture unfolds like a vast canvas. Oumuamua, Borisov, Atlas, each a brushstroke, each a line suggesting form. The painting is not yet complete, and perhaps it never will be, but already the shapes are emerging, and already the watchers on Earth feel the weight of those shapes. We are learning that the universe is not quiet, that interstellar objects are not rare, and that our own story is entangled with currents larger than we had imagined. The skies will bring more, the telescopes will find them, and with each new discovery, the pattern will grow clearer. Perhaps it will reveal only the richness of natural creation, a galaxy filled with fragments wandering endlessly. Or perhaps hidden among them, the footprints of intention will become undeniable. For now, we drift between those possibilities, gazing upward, aware that the watchers may themselves be watched. And in that awareness lies both wonder and unease, the twin companions of discovery, the emotions that carry humanity deeper into the night sky and deeper into its own reflection. Chapter 10. When Fear Becomes Wonder. In the vast quiet of the cosmos, where certainty fades into shadow, there lies a strange duality. The more we search for answers, the more questions seem to surface. What began as careful observation has transformed into a personal journey, as scientists find themselves not just mapping trajectories and energies, but confronting the fragile wonder of their own place in the universe. As the data piled up, so did a subtle shift, from fear of the unknown to a deep, gentle curiosity. What does it mean, this silent visitor that stirs both doubt and awe within us? The patterns of interstellar visitors, the strange alignments, the whispers of energy and glow, had all built toward a question that was no longer scientific alone. It was human. It was personal. Because behind every calculation, every telescope image, every line of data, there was always the observer. And observers are not machines. They feel awe, uncertainty, sometimes even fear. They know that knowledge is never neutral, but always coloured by the meaning we give to it. And so, as scientists and dreamers gazed upon this wandering stranger and the questions it carried, they also turned inward, reflecting on what it meant for us. Not just what it was, but what it made us feel and what it revealed about our own fragile place in the cosmos. Fear is not always the enemy of discovery. Sometimes it is its companion. Imagine standing at the edge of a dark cave with only a faint light in your hand. Fear urges caution, but curiosity compels you forward. That is how science often moves. Not in bold, reckless leaps, but in hesitant steps into the unknown, each step illuminated just enough to see the next. With 3i Atlas, with Oumuamua, with Borisov, humanity found itself at the mouth of such a cave. The darkness was immense, the shapes inside unclear, but there was the flicker of something, perhaps treasure, perhaps danger, perhaps simply mystery itself, and fear became the spark that made the light burn brighter. Curiosity has always grown in the soil of uncertainty. We build theories because we cannot rest with gaps. We search the skies because the silence itself begs a response. Even the most unsettling questions, could this be artificial? Could this be a beacon? Could we already be observed? Became fuel for inquiry. For some, the fear that the unknown might conceal danger was balanced by the realization that the unknown also conceals wonder. What if these lights, these paths, these improbable alignments were not signs of menace, but signs of the universe inviting us to learn more, to think bigger, to leave behind the comfort of small explanations? Fear and wonder intertwined, like threads in the same tapestry. And wonder, when it grows large enough, can soften fear. Imagine the vast scale of time that a single interstellar fragment has traveled. Imagine drifting for millions of years across gulfs between stars, carrying within you the frozen memory of a system that no longer exists. Imagine tumbling silently, never aging, never corroding, just waiting for chance to place you in the path of a curious species with telescopes pointed outward. That story itself becomes a kind of lullaby, cosmic in scale, gentle in rhythm, whispering that the universe holds more than we can measure, and that even fear is just another shade of wonder when seen in the right light. Still, some could not resist the more dramatic possibilities. What if this light, this energy, this persistence was not just frozen memory, but deliberate signal? What if this object were technology, a probe sent across the dark? The idea was not fantasy. Humanity itself has already launched emissaries into interstellar space. Voyager 1, Voyager 2, Pioneer, New Horizons. Tiny messengers, carrying plaques and records, drifting into the unknown. If we have done this with our small and newborn technology, why could another not have done the same long before us? What if this was not a rock at all, but a relic of an older civilization, patient and silent, carrying information across the stars? The thought carries both awe and unease. Awe, because it means we are not the first, not alone, but part of a lineage of beings who look up and wonder. Unease, because contact with the unknown is unpredictable. What would it mean to know we are observed? To realize that intelligence beyond us is aware of our presence? Even if the watcher meant no harm, the balance of scale between their abilities and ours could be staggering. Humanity has always told stories of being small before giants. In myth it was gods, in old tales it was titans, and now it might be civilizations whose power is measured in energies we can barely imagine. But if it is natural, the mystery is not smaller. If this glow, this steadiness of light, comes from some process not yet catalogued, then our physics, our cherished models, are incomplete. The cosmos would be stranger than we thought, and that strangeness itself is profound. Perhaps there are chemical dances within ice and dust that mimic technology. Perhaps decay or pressure or quantum processes release steady luminescence over spans of time far greater than we expect. If so, then nature is not only creative, it is creative in ways that still escape our imagination. To admit that is humbling, and humbling truths often feel like fear before they turn into wonder. We live at the boundary of two great possibilities, and both are unsettling in their own ways. Either we are alone, making meaning out of natural but misunderstood phenomena, or we are not alone and have glimpsed evidence of others. Which truth is more frightening? To walk in silence, convinced the universe is empty, or to walk in company, aware that eyes we cannot see may be watching? The mind drifts between the two, as if rocking gently in a cradle of uncertainty. The stars above become both comforting and questioning. It is here, in this uncertainty, that human reflection becomes most important. These questions are not just about the sky, they are about us, about how we face the unknown, about how we balance fear and curiosity, about how we choose to tell our own story. When Galileo turned his telescope to Jupiter's moons, there were those who feared what it would mean for human importance. When Darwin sketched the first tree of life, some trembled at the thought of humanity as part of nature, not above it. And now, with 3i Atlas and its mysteries, we face another moment where fear and wonder mingle. History shows us that wonder often outlasts fear, that curiosity pushes forward even when dread whispers to stop. Close your eyes for a moment and imagine standing on a quiet hillside at night. The stars are clear, unbroken by city lights. Above you passes a faint streak, a traveler older than Earth's civilizations. You do not know if it is stone or machine, random or deliberate. You only know that it shines, steady and strange. What do you feel? Is it fear? Is it awe? Is it the recognition that you are small? Or is it the sudden rush of connection, that whatever it is, it has linked your story to a greater one, a story that crosses light years and millennia? Perhaps this is the greatest lesson, that fear itself can be transformed. What begins as dread of the unknown can become reverence for the vastness, an almost spiritual awareness that the universe is deeper, richer, stranger than we can hold in words, that every fragment of rock, every comet, every glowing traveler is not just an object, but a chapter in a story still unfolding, a story that includes us. And whether that story is written by physics alone or by the hands of other minds, it is larger than us, and that largeness is both daunting and beautiful. Some scientists confess quietly that they do not know which truth they would prefer. Some find comfort in solitude, in the idea of being alone but free. Others long for company, even if distant, even if immeasurable in power. And some admit that either answer would be overwhelming. For now, all we can do is wait, watch, and wonder. Wait for new instruments to gaze deeper, watch as data flows back, and wonder at every possibility that remains open. The night sky has always been a mirror. When we look into it, we see not only stars, but ourselves, our fears, our hopes, our questions. 3 Atlas, like Oumuamua and Borisov before it, is such a mirror. It reflects back the truth that our understanding is provisional, that our place in the cosmos is still being written, that the story is not yet complete, and maybe it never will be complete. Maybe that is the beauty, that the universe forever gives us mysteries just beyond reach, keeping curiosity alive. The greatest fear then is not one or the other answer, but the awareness that either could be true, to be alone or not alone, to find that we are the sole voice in the cosmic dark, or one voice among many. Both are profound, both are unsettling, both remind us how small we are and how vast the universe is. And perhaps in that realization, fear and wonder finally meet, blending into a quiet awe that makes the mind both restless and calm. Chapter 11. The Future of Interstellar Discoveries. The story of 3I Atlas, of Oumuamua, of Borisov, has carried us through mystery after mystery and left us with more questions than answers. But science does not stand still. The future waits, and with it the promise of sharper eyes, wider surveys, and deeper insight. If the past decade gave us 3 such visitors, then the next decade may bring dozens. And with each one, the veil of cosmic ignorance will thin. Or perhaps paradoxically, it will thicken, for sometimes the more we learn, the more questions multiply. Astronomers are preparing for this future with anticipation and unease. The Vera Rubin Observatory, perched high in the Chilean Andes, will soon open its wide eye on the sky. Its mission is nothing less than to scan the heavens night after night, recording changes, motions, flickers, and wanderers with a depth and frequency never before attempted. Where older surveys might scan once in a week, Rubin will sweep the entire sky every few nights. That means no traveler, no matter how faint, no matter how fast, will easily slip past unnoticed. If Oumuamua was the one that got away too quickly, if Borisov was the rare chance aligned just right, then Rubin promises to catch what comes next, and the next after that. Imagine its gaze, broad and unblinking, sweeping across the stars like a lighthouse across the sea. Each pixel of light, each moving point, a candidate for further study. With such precision, astronomers expect that what once felt like miracles of chance, an interstellar object spotted just as it passed, will become routine. Not one every decade, but one every year, perhaps even every few months. Soon we may speak of interstellar visitors not as extraordinary, but as a class of objects as familiar as comets once were. And yet, familiarity may not bring comfort, for if their arrival becomes frequent, the anomalies too may multiply, forcing us to question how normal truly is. Consider what that means. If each visitor is like a message in a bottle from another star, then soon we may have a whole shoreline cluttered with bottles. Some may be ordinary, chunks of ice and rock thrown loose by chaotic births of planets. But what if even one in a dozen is not? What if even one carries signatures that refuse to fit the models? A glow too steady, a path too precise, a composition too pure? Then every new detection will carry a quiet tension, the question unspoken but present. Is this the one? Have we at last stumbled not upon nature but upon something beyond it? The Nancy Grace Roman Space Telescope, soon to follow, will peer in infrared with exquisite sensitivity. Infrared light carries the warmth of worlds, the glow of dust, the secrets hidden from visible eyes. Roman will not just see where these objects are, but sense what they are made of, how they shine, how they absorb and release energy. And then there is JWST, already unfurling its golden mirrors to catch the faintest whispers of light from the early universe. Though designed for galaxies and exoplanets, it too may turn its attention to a wandering visitor, peeling back the layers of its spectrum like pages of an ancient book. And beyond these giants, missions are being dreamed that may do more than watch, they may chase. Concepts for spacecraft that could intercept the next interstellar traveler are being drafted. Engines that could accelerate fast enough to match a hyperbolic orbit. Probes that could close the gap and photograph a visitor up close. Imagine it. Not distant pixels, but detailed portraits. Not faint glimmers in a telescope, but icy cliffs, glowing surfaces, or metallic ridges caught under alien sunlight. The idea feels like science fiction, yet plans are quietly laid because the age of interstellar discovery is not in the distant future. It has already begun. As the tools sharpen, the statistics shift. What once seemed rare now seems common. The models suggest that interstellar space is crowded, littered with debris from the formation of countless systems. Every star births and loses worlds. Every system throws fragments into the void. Over millions of years, those fragments drift, and a tiny fraction pass near us. What once seemed improbable is, with better instruments, revealed as inevitable. The universe is not a pristine void. It is a river full of currents and stones, and we are standing in its flow. And yet, with each discovery, the sense of normalcy thins. If we find a dozen, and one behaves oddly, we may dismiss it as an outlier. But if we find a dozen, and 3 or 4 behave oddly, the unease grows. If the anomalies pile up, glows without explanation, paths too precise, energies too high, then the narrative begins to fracture. We are forced to consider whether we are not alone in this river, whether some of the stones are shaped, some of the currents guided. The prospect unsettles not because of proof, but because of accumulation. A single anomaly can be explained away, but a cascade of them becomes a chorus, and a chorus can no longer be silenced. Imagine a future in which every year brings new debates, new arguments, new midnight whispers among astronomers asking the same question they cannot quite admit aloud. Are we being watched? To stand at such a threshold is dizzying. For centuries, we assumed the stars were silent. For decades, we assumed visitors from other systems were unlikely. Now we are poised to watch them arrive not as rare miracles, but as regular guests. And with each arrival, the line between natural and artificial may blur, teasing us with possibilities. Close your eyes and picture it. Night after night, observatories around the world watching the skies. Data streams flowing like rivers of light, computers flagging candidates, astronomers tracing orbits on glowing screens. A faint streak appears, then another, each one from elsewhere, each one ancient, each one carrying within it the story of another place, another star, some ordinary, some extraordinary. And humanity, restless and curious, waiting for the one that changes everything. What will it feel like when the first survey reveals dozens in a year? Will excitement eclipse fear, or will fear bloom quietly beneath the surface? Will people look at the night sky with greater wonder, or with quiet suspicion? The universe may feel less empty, but also less safe. For what if the patterns hint at something deliberate? What if the regularity is not just chance, but choreography? The collapse of normalcy is not always catastrophic. Sometimes it is the birth of a new worldview. Once, Earth was thought to be the center, and its dethronement was unsettling, but it opened the cosmos to us. Once, we thought species fixed, and their fluidity was shocking, but it deepened our understanding of life. So too with interstellar visitors. To accept that they are common is to reshape our sense of the galaxy, to realize that the void is alive with motion, that fragments, and perhaps more than fragments, are passing constantly. It is unsettling, but it is also liberating. It tells us we are part of a larger web, participants in a cosmic circulation far older than our species. And still, the fear lingers. For some scientists whisper that the true danger is not proof, but implication. If even one of these proves to be artificial, then the galaxy is far more crowded than we imagined. Not crowded with rocks, but with eyes, with minds, with watchers. If that is true, then our solitude has already ended, and we may have to reckon not with whether we are alone, but with why we are being observed, and by whom. The thought drifts into the imagination like a shadow across the stars. A civilization capable of sending probes across light years would be ancient, patient, powerful. Its reasons may be unknowable, its intentions unreadable. It may not even be interested in us at all, just cataloguing, just watching the way we watch distant exoplanets. But the realization that the watchers exist would still change everything. It would redefine our place, our story, our sense of control. And it is this possibility, the quiet suspicion that the universe may already be aware of us, that keeps the fear alive even amid the wonder. The future of interstellar discoveries is therefore not just scientific, it is psychological, it is cultural, it is human. Each new detection will not only expand data, but expand the boundary of our imagination, of our myths, of our sense of safety. And perhaps this is the real lesson, that discovery is never neutral. It always touches the heart, reshapes the dream, unsettles the sleep, but it also inspires, awakens, opens. Fear is never alone. It always comes with its twin, wonder. And so, as we look forward to the next decade of telescopes, surveys, and missions, we stand at a strange threshold. The darkness ahead is thick with travelers, and soon we will see them more clearly than ever before. What will they show us? More comets, more debris, more ice and stone, or something stranger, something that shifts the narrative of our place in the galaxy? Perhaps both. Perhaps the truth will come in layers, natural and artificial mingling, each revelation changing us little by little, year by year. Until then, we wait, we watch, and we dream, for the night sky is about to grow more crowded, and with it, our sense of the possible. The bottles will wash ashore, and we will read their messages, one by one. Some will be fragments of other worlds, some may be whispers from minds we cannot yet imagine, and in every case, we will find not just data, but reflection. For in every visitor we see not only the universe, but ourselves, curious, fearful, and forever reaching into the unknown. Chapter 12. Reflections Beneath the Silent Sky. Tonight, after tracing the path of 3 Atlas across numbers, probabilities, and possibilities, we find ourselves not at an answer, but at a pause beneath the stars, where silence feels almost like part of the conversation. Scientists wondered why it glowed, why it travelled with such precision, why it appeared so soon after the last interstellar visitor. They wondered how it could shine with the strength of 10 gigawatts, a lighthouse adrift in the void. They wondered whether chance alone could explain its encounters with planets, or whether something deeper shaped its trajectory. And beneath each of those questions lingered the one we began with. Why does this object inspire unease? Why does it awaken fear as much as curiosity? Perhaps it is because it reminds us of how little we know. For centuries we mapped our skies and thought we understood the order of things. Then came the visitors. First one, then another, now a third. Each arriving like an uninvited guest, reminding us that the boundaries of our solar system are not walls, but open doors. And if doors are open, they are open both ways. Yet fear, when looked at closely, often shares the same shape as wonder. To be unsettled is also to be awake, to notice, to lean in. A scientist staring at the data may feel a chill, but also a thrill. the chance to learn something new, something that refuses to fit old categories. If 3i Atlas is a comet, it is a comet unlike any we have studied. If it is a machine, then we are not alone. Which possibility is stranger? Which is harder to face? The truth is, we do not yet know, and that not knowing is its own kind of gift. Imagine the object now, gliding far from us in the darkness, its tail scattering ice into the sunlight, or its surface concealing something more deliberate. From Earth it is a point of light, barely distinguishable from the countless other points around it. And yet, unlike the stars, it is moving, cutting across their patient stillness, carrying with it the story of another place, another system, perhaps another civilization. The telescopes will keep watching, the scientists will keep writing, the questions will keep multiplying. But here, for us, it is enough to let the mystery rest gently in our thoughts, to imagine the night sky not only as a dome of beauty, but as a living sea with travelers drifting through, sometimes seen, sometimes unseen. And so the story circles back to us. What do we fear more, the silence or the reply? What do we hope for, that the universe is filled with neighbours, or that it is vast and empty, and we are the rare anomaly? In the end, the greater mystery may not be out there among the stars, but within us, in the way we respond to them. Tonight, as you close your eyes, you may picture 3i Atlas still moving, still glowing, far beyond the reach of our world. You may imagine it as ice and dust, or as something more. You may let the questions drift like constellations above you, quiet, unhurried, waiting. The universe does not answer quickly, it does not need to. Beneath that endless sky, we remain watchers, and the watchers too are watched, by their own reflection in the cosmos, by the mysteries they cannot yet name. Fear becomes curiosity, curiosity becomes wonder, and wonder in the stillness of the night becomes a kind of peace. The stars remain, and so do the questions, and that is where we leave them, and you, in the silent sky.